All right, so I'm going to really briefly go over the 3 different labs you completed for this unit. And the first one was the Pennies in the Vinegar Lab. So what happens for pennies, their outer coating is made out of copper. And the reason why pennies often will look really old is not, or dirty, is not because they're actually dirty or really old, is because over time, the copper reacts with oxygen in the air and it forms copper 2 oxide. This copper 2 oxide has that old grungy look to it. All right, so that's the reaction to explain why pennies often look old and dirty. Now, when we added the pennies to the vinegar, which is acetic acid, a double replacement reaction occurred, and we didn't study that in detail because we hadn't gotten to double replacement reactions yet. But all you need to know is that the vinegar solution, by adding copper oxide to that vinegar solution, to the acetic acid, what was formed was copper chloride, okay? And so then when you added iron nails to the vinegar solution, the copper chloride solution, what resulted was a single replacement reaction. So the iron kicked the copper out, creating iron chloride. This was now the new solution. It used to be copper chloride, now it's iron chloride, and copper was kicked out. Now that copper, when a metal is by itself, for all of them except for mercury, they are solids. And so as a result, what was forming on your iron nail was actually solid copper. And we saw that in the form of that dark solid that was forming on your nail. Okay, so that was lab number 6. You saw a synthesis reaction, you saw a single replacement reaction, and actually, if you actually wrote out copper oxide reacting with acetic acid, you would see a double replacement reaction, but we hadn't gotten there yet. In lab 7, the lab in which you put an egg into acetic acid, eggs, their actual shell is made out of calcium carbonate. So calcium carbonate, when it's allowed to react with acetic acid, HC2H3O2, it has a double replacement reaction. The calcium forms a new compound with the acetate ion, calcium acetate, and then hydrogen forms a new compound with the carbonate ion, or carbonic acid. All right. Now, we didn't actually observe carbonic acid forming because what happens is as soon as that carbonic acid forms, it actually decomposes into water and carbon dioxide. This is an acid decomposition reaction producing water and the nonmetal oxide. All right. So what you observed with your eyes was the calcium carbonate, the solid, disappearing over that 48-hour period. And what you could actually see were bubbles forming, and that was the carbon dioxide being produced. You couldn't see the calcium acetate forming, and you couldn't see the water. But what you did see was that this solid was disappearing and bubbles were forming. Okay, so that was lab number 7. In lab number 8, that was your virtual lab where you were adding different solutions and seeing if a precipitate formed by considering your solubility rules. So one example, and this was actually not something you observed, I was just going to give you an example. You were asked for any of the net ionic any of the reactions that formed a precipitate where you could write a net ionic. I wanted you to write out that net ionic reaction. So for example, if I gave you lead 2 nitrate and I allowed it to react with sodium chloride, right? What would the net ionic reaction be? Well, if I wrote the complete reaction, Pb and Cl would form a compound, PbCl2, and Na and NO3 would form a compound, NaNO3. To write the full ionic, if you want to write the full ionic, you don't have to, but to write the full ionic, I know that lead nitrate, sodium chloride, and sodium nitrate are soluble, so they're going to break up into their ions, Pb2+, 2 nitrates, 2 sodiums, 2 chloride ions, 2 sodiums, and 2 nitrates, and the lead 2 chloride stays together because it's insoluble. So your net ionic reaction shows just Pb2+ plus 2Cl minus gives you PbCl2. Now, your nitrate and sodium ions, they remain in solution, right? And so since they are spectator ions, they remain in solution. When I draw my particle diagram like I asked you to do for your net ionic reactions, you would see sodium ions floating in the solution and you would see nitrate ions floating in solution. The solid would be PbCl2, so you would see that forming at the bottom. Now, technically, officially, and we haven't learned this yet, technically there would also be some lead ions left over in solution, but I don't expect you to draw that. You can just draw your spectator ions. That's fine, all right? So looking at these 3 labs, we have a synthesis reaction, a single replacement reaction, a double replacement reaction, a decomposition reaction here, and then another double replacement reaction with the formation of a precipitate.